Okay, this is question number 3 on page 66. If a rocket starting from rest is given constant acceleration and moves 1,000 meters during the first 20 seconds, how far does it move during the third second? So if you draw a VT graph, you can see the velocity start from 0 all the way, having constant acceleration until 20 seconds. So the area on this graph should be the displacement. That's 1,000 meter given. So the question is really actually asking for what is the distance traveled during the third second. So that's exactly the distance between the 2 and the 3 seconds. So this is the one we need to find out. Okay. So now first of all, given the information, so we need to pick a time interval that we can apply formula to find out the acceleration first. So I would pick starting from 0 to the 20 seconds. So during this time period, we know the time, of course, equals 20 seconds. We know the V initial velocity equals 0. And then we know the displacement equals 1,000 meter. Okay, from the information here, we can apply to the formula d equals VIT plus 1/2 AT squared. And it's easier, this is gone because initial velocity equals 0. So 1,000 meter equals 1/2 A, then 20 squared. So we can find out the acceleration is actually equals 5.00 meter per second square. You can actually calculate it yourself. And from after we know the formula acceleration, we can find out the velocity at 2 seconds and at 3 seconds. That's one way. Another way, you can find out the total displacement traveled during 3 seconds, and then subtract the total distance traveled during the first 2 seconds. So I give a different color for this. The displacement traveled during the first 2 seconds, right? So if I label this as D1, 2, and then this is going to be the D3. So we can do this way. If we look at the time period from 0 to 3 seconds, so we can know the initial velocity equals 0, t equals 3.00 seconds, and acceleration, of course, is 5.00 meter per second squared, which we found out earlier. So we can find out from the information here that D3 0. Okay, I should just say D1, 2, 3. That means the seconds, the first 3 seconds. So that should be V initial t plus 1/2 A squared, and then this is 0 again. It's gone 1/2. A is 5.00, and t is just 3 squared. So we can find this out. We can do this calculation later. And then if we look at 0 to 2 seconds, so we also got the information V initial equals 0 and the t equals 2.00 seconds. Acceleration is still the same, right? And same thing, we can find out displacement traveled during the first 2 seconds. So we can put 1, 2, and it's very similar, should be 1/2, 5.00, and then 2 squared. And you don't have to calculate this because eventually the question asking for D3, they just simply we use D1, 3. That's the displacement traveled during the first 3 seconds. Subtract the displacement traveled during the first 2 seconds, right? That's the displacement traveled during the third second. So subtract 2 displacement, you calculate there. We can actually put this down. 5 times 3 squared That's 1/2 times 5 times 2 squared, right? So you calculate, eventually you should get 12.5 meter. That